In this lesson, we're going to learn about compound inequalities. So we've talked about several different types of inequalities, and we've graphed them, and we've solved them, and now let's put multiple compound or multiple inequalities together, and that makes a compound inequality. So in this exploration here, we're going to describe these intervals using two inequalities. So we'll do the first one here together and then cut you loose on the rest. So take a look at these numbers. Here's some numbers that are being described, and the ones that are shaded. And so we want to know what is true about those. Well, we'll notice that these numbers, this line right here, is greater than -6. These numbers here are greater than -6 or equal to, right? So that's the first thing we notice. We notice that x is greater than or equal to -6. Okay? And so that's these guys. But something else is also true about them, because 8 is greater than -6, but 8 is not shaded. It stops. So we need something else to be true. We need the numbers that are marked to be less than 3. So we're going to say, and something else is true, and the x values that are labeled are less than 3. So two things that are true. X is greater than -6, and it's less than 3. So that describes all these numbers in the interval. So now what I need you to do is pause the video for a second and go ahead and write two inequalities for each of these graphs. Notice, by the way, there's some vocabulary here. This is called a half open, and this one right here, this is also a half open, and so on. It's in a closed and open interval. So those names will be kind of important. So pause, try it out. Now you should have noticed that here we have a couple things. We have x is greater than -5. Did you get that? And x is less than or equal to 4. Okay, so it includes one side, includes the 4 side, but not the other side. Here, x is greater than -4 and or equal to x is less than or equal to 5. Over here, x is greater than -3 and x is less than 6. So two things are true. These are what we call and inequalities. Both of them have to be true to describe all these numbers. It doesn't go on forever. It's bounded in between these two numbers. So did we use an and or an or? Well, pretty clearly we used an and. And why do we use an and? Well, because both had to be true. That's what gives us an and inequality. Both of them are true at the same time. Jump to the next page here. We have our second exploration. So let's do the same idea here now. We want to describe all the numbers that are graphed here, all the numbers that have an arrow or a dot with them. So, first one we have here, these are all the numbers that are x is less than or equal to -6. What describes all these numbers on the right? Well, these are all the numbers that are greater than 3, but not including 3. Okay, so we're going to pick a number in one of these, and we're going to combine these with an or. The word that goes in between these is or, because any specific number cannot be both over here and over here at the same time. It's got to be in one spot or the other spot. So these are or inequalities. Try the rest here. Go ahead and pause it and answer the rest of the questions in exploration 2. Now that you've tried the rest, let's see what we've got. We've got x is less than -5, not including it, or x is greater than or equal to 4. Here we've got x is less than or equal to negative 4, or x is greater than or equal to 5. And lastly, x is less than or, not or equal to, no or equals to there. X is less than negative 3, or x is greater than 6, not including. And these are all, again, or inequalities. Okay, and the reason why they're or inequalities is because they cannot, any number cannot be in both spots at the same time. In the and inequalities, you can satisfy both at the same time, but here you can't. So it's an or. You got to be in one or the other spot. Okay. So how can we use inequalities to describe intervals on a number line? Well, we can use inequalities either as a going on forever. Okay, so we have inequalities that never end. Okay, like x is greater than 5 all by itself. Or we have inequalities that are bounded, meaning that they have two endpoints, like the and inequalities. Or we have two inequalities going opposite directions. And so if they don't end, they're called unbounded. They go on forever, like x is greater than 5. Or they can be x is less than 5 and greater than 2. That's all the numbers in between. Or we can say x is less than 2, or equal to whatever, or x is greater than 5. These would be two arrows going in different directions. There. Okay, so those are different types of inequalities. So or inequalities, we have arrows going in opposite directions, and inequalities are graphed in between the points.